Hi, I'm Alex Bock, Technical Lead and Lead Developer for OpenSpace. In this tutorial video, we will fire up OpenSpace and learn to navigate, control time, and begin exploring our universe. You can find a written version of this guide on our documentation page at docs.openspaceproject.com, and the link is in the description of this video. This tutorial assumes you have already installed OpenSpace on your computer. If that is not the case, pause this video now and find the link in the description to the Step 0 tutorial, which will walk you through downloading and installing the software. Alright, now that we have an OpenSpace version on our system, we can go into the OpenSpace folder and it should look something like this. All of the many files and folders in here can be used to customize your experience with OpenSpace, but we'll leave that for a later tutorial. For now, let's open the bin folder where the main OpenSpace application is located. Here we have the OpenSpace.exe, and to start OpenSpace, we just double-click it. If everything is correctly set up, you should now see two new windows pop up. The first one is the console window with black background and green text. We can ignore that for now, but it can be useful to look at error messages in case they show up. The second, more interesting window is the launcher for OpenSpace. In the first dropdown, we can choose which profile to load, which basically means which datasets we want to explore. For this tutorial, we'll use the default profile, as it already contains plenty of interesting data to visualize. The second option is the window configuration dropdown that tells OpenSpace how to display all of the data. Again, we'll leave it at the default setting, which means that we'll get a standard window that covers 2/3 of our monitor. The little cogwheel down here gives access to some more advanced settings, and we can ignore that for now as well. All there's left to do is to press the big Start button to go to space. OpenSpace is now loading the selected default profile with a standard window configuration. We see the names of all the different datasets that are being loaded. How long the loading takes depends on the computer and the profile that we selected. For the default profile, this should be somewhere around 30 seconds to 3 minutes. When we pick different profiles later, this is also the time where additional datasets are downloaded. Your internet connection will then determine the time needed to load a profile. However, all downloads are saved between runs, so we only need to wait this longer time once. Once the loading is finished, we see our Earth as it looked like yesterday. We can now drag the corner of the window to resize it, or use the Maximize button in the top right to make it full screen. The first thing I'll do to make this tutorial easier to follow is to pause the time in OpenSpace by pressing the spacebar. A central concept for navigating in OpenSpace is the focus object. This is the object around which all camera movements happen. When rotating, we are rotating around the focus object. When zooming, we are always zooming towards or away from the focus object. As we just started the default profile, Earth is our focus, which we can verify here in the toolbar at the bottom. In order to rotate around the Earth, we click and hold the left mouse button and then drag the mouse in any direction. The camera starts rotating around Earth while we are holding the left mouse button. If we let go of the left mouse button, the friction of the camera kicks in and the camera slows down. Let's try it again, but move the mouse a bit further after we click the left mouse button. We are rotating faster around the Earth the further we move the mouse. Try to rotate the camera back so that we see the illuminated side of Earth during the day. For the next type of movement, let's click the right mouse button and move the mouse down a bit. We are now zooming away from Earth. Likewise, if we click and move the mouse up, we start zooming towards the Earth. So to recap, left mouse button rotates, right mouse button zooms. The next interaction uses the middle mouse button. If you don't have one, you can do the same by holding the Shift key and using the left mouse button. Both do exactly the same. With the middle mouse button, we roll around the line connecting the camera to the focus object. Holding the middle mouse button and moving the mouse to the left rolls the camera to the left, moving it to the right rolls it to the right. There's a good chance that the North Pole of Earth is no longer at the top of Earth, which is fine since there is no up in space, but we can use the middle mouse button to fix that and restore the view of Earth that we're all familiar with. The next interaction is panning the camera. This is done by holding the Control key and using the left mouse button. This keeps the camera in the same location, but pans it in place to look in different directions. We only use small movements in the beginning, as it is fairly easy to lose track of Earth this way. We see that the rotating and zooming still work as expected. But if we roll using the middle mouse button, you might not expect the result. We are still rolling around the line connecting the camera to the focus node, which causes this sort of offset roll to occur. If we still want to roll around the center of the screen, we can use the last of our 5 interaction methods and hold the Control key again, But instead of the left mouse button to pan, we now press and hold the middle mouse button again. Now we roll around the center of the screen. Rolling without the control key. Rolling with the control key. With this, we have now covered all of the mouse interaction that exists in OpenSpace. To recap, left mouse button rotates, right mouse button zooms, middle mouse button or shift and left mouse button rolls, control and left mouse button pans, and control and middle mouse button rolls around the center of the screen. As you have noticed, all of these interactions have frictions acting on them, meaning that if you let go of the mouse button, it takes a few seconds before the movement stops. Up in the top right, we have 3 buttons to toggle the friction for different movement types. If we click on the rotation button, we now have disabled the friction for rotations. So if we start rotating and let go of the left mouse button, the rotation will continue indefinitely. If we click the button again, we turn the friction back on and the movement will stop quickly. We use this regularly to maintain a slow movement while, for example, digging through the menu. It is so useful that there is a keyboard shortcut for this, the F key. Pressing F will toggle the rotation friction, exactly the same as clicking that button in the top. Likewise, Shift F toggles the zoom friction, and Control F toggles the roll friction. Note that the roll friction also applies to the panning, which might be a bit unintuitive at first, but will make sense later. Also, if you click on that little eye icon in the top right, you can see the keys for the different friction modes. It's really useful to know these by heart, which will happen automatically over time. Now that we have already started looking at this top bar, let's look at the rest of the user interface that we see on screen. Here at the top, we have the menu bar. We can learn more about the profile that we have currently loaded, open other panels of the user interface, access other helpful material, and find the friction buttons. Just below the menu bar, we have the dashboard. The contents of it are completely customizable, but in the default profile we see the distance of the camera to the focus object, the average frame rate, and the position of the camera in decimal, latitude and longitude, as well as the altitude above the surface. At the bottom of the screen, we have the toolbar, which gives you access to many functions within OpenSpace. For this initial tutorial, we will focus on the 3 leftmost buttons on the toolbar, as these are also used the most. Furthest on the left, we have the Scene panel. This gives you access to all of the settings that relate to things in the virtual scene, such as the Earth, the Moon, other planets, etc. This panel is split into 3 parts. At the top, you see the current focus, which of course is still Earth. Below there are the quick access options, which are objects defined in the profile to be particularly interesting. Below that, we have the rest of the tree that we will be digging into in just a few moments. We can close this panel either with the X button in the top right, or by right-clicking on the Scene option in the toolbar. The next button is the Focus panel. This allows us to change which object is currently the focus of the camera. Remember that all camera interactions are always relative to the current focus object, which is why during our previous exercise we always rotated around the Earth. In this panel, we change what that focus object is. The last panel we will look at in here is the Time panel, which allows us to change what we call the in-game time in OpenSpace. We see the date here and that the current rate of time is set to 1 second per second, which means real time, as for every second for us, 1 second would happen in the simulation if we were not paused. In this panel, we can change the date directly, as well as control how fast the time progresses inside OpenSpace. With this knowledge under our belt, let us start exploring a small portion of our observable universe. The weather that you see on your Earth will look slightly different from what we're seeing in this video, since you'll be looking at Earth on a different day. These images are captured from the NOAA 21 satellite, which is covering Earth with images every day, so we can go to any day that we want and see what the weather was like that day. We start on yesterday, since there is a complete map of Earth available. Today hasn't happened yet, so that map would be missing data. If we rotate around Earth, we see 3 lines in the vicinity of our planet. We use these trails often to show where an object is coming from. The blue line is the trail of Earth, so it indicates the movement of Earth around the Sun. Looking back at the trail, we can see that it hits Earth almost exactly at the terminator, the place where day turns into night, which makes sense, since the day side is the part of Earth pointing at the sun, the night side is the part of Earth pointing away from the sun, and the movement of the Earth is exactly in between. The other two lines are the orbits of our two manned space stations, the International Space Station, ISS, in orange, and Tiangong, the Chinese space station, in red. Let's zoom into the ISS. To do that, we first need to change the focus of the camera away from Earth, so we open the Focus menu, and if we scroll down, we find the entry for the ISS. We could also search for it, the result would be the same. As soon as we click on the ISS entry in the panel, the camera shifts focus towards the ISS, which is at the end of the orange trail. Just as before with the Earth, we use the right mouse button to zoom in, but now we are zooming towards the ISS and not the Earth. Note that depending on the location of the ISS, you might need to rotate around to avoid flying straight through the Earth. It usually looks very nice to approach having the day side of the Earth at a grazing angle. Here, we can now see the model of the ISS in front of us, and I would say that we don't need the trail anymore. So let us open the Scene panel and search for ISS. If we click that checkbox next to ISS Trail, the trail behind the ISS disappears. And we can continue flying closer to the ISS and rotate around to see the space station in orbit. All of the camera interactions we learned earlier work exactly the same as before, except that now we are moving relative to the ISS instead of Earth. Alright, let's zoom out again. To turn on the trail again, we toggle off the zoom friction with Shift F to continue the zoom, so we can click on the checkbox next to ISS Trail again. If we try to rotate, it looks a bit offset, since we are still focused on the ISS. You already know how to change the focus in the Focus panel, but we can also do that from the Scene panel. So if we clear our search, we can go to Solar System, Planets, Earth, and we can find our Earth right here. It has a small focus button right next to it, with which we can focus our camera back on Earth. However, we can also click the Kebab menu, the three vertical dots, next to the focus button to open a separate menu and pick the Fly To button. This will automatically fly the camera to a good distance from Earth and also change the focus of the camera to Earth. Tiangong and the ISS are of course not the only things humanity has launched into space. With the Scene panel open, we can look at the Satellites category and find the GPS navigation satellites. Just like the ISS trail, clicking on the checkbox next to the GPS turns on their trails. However, we need to zoom out a bit more as they orbit at about 20,000 kilometers distance from Earth. Compared to the ISS, the GPS satellites have a shorter trail, but of course we can change that. Clicking on the GPS text, we open the Property panel for the GPS satellites. We can move all of these panels around by clicking and dragging their title. I like to dock the Property panel here on the right side of the screen to give us a bit more space to work with. In here, we can now change the properties of the GPS satellites. Under Appearance, we find the Trail Fade, which controls how long the trails of an object should be. Increasing it to about 25 shows us more of the GPS constellation. Next to most properties is an Info button that will tell us more about what this setting is doing. One important thing to highlight here as we start making changes to these properties is that none of these settings are saved between OpenSpace runs. While this might be annoying, it also gives you complete freedom to play around with any setting, as it is impossible to permanently screw up anything. In the worst case, you just restart OpenSpace and everything is back to how it was before. So definitely experiment with settings. While we're here, we can also change the color from the orange to maybe more of a yellowish green color. For now, let us close the Scene panel, which takes the Property panel with it, and open the Time panel instead. This panel controls both time and the progression of time. Let us go back by a day and notice how Earth loses its images for a few seconds as we are now on a different day and we need to retrieve the weather information for this new day. We are still paused, but if we press the spacebar again, we start moving at real-time speed, though we can't really see the movements of the satellites. If we click on the Forward button, we shift to the next faster simulation time, and the toolbar now says 5 seconds per second. So for every second that passes for us, 5 seconds will pass inside OpenSpace. Clicking the Forward button 3 more times moves us to 5 minutes per second, and now the GPS satellites move along their orbit and we can see their regular motions around the planet. We can let the time progress even faster until we roll over to yesterday's date again, and we see our familiar weather pattern. We pause the time again with the spacebar. The forwards and backwards button to control the passing of time are also mapped to the left arrow and right arrow keys on your keyboard, and we can even move with a negative delta time, which means that if we were to unpause, time would now tick backwards at 1 second per second. Now let us leave our own planet behind and start zooming out. We turn off the zoom friction with Shift F and start moving away from Earth. We can see the orbit of the Moon in red, and zooming further out, we now see the trails of the other planets in our solar system. As we continue zooming out, at a distance of about 1 light month away from Earth, our Sun is represented with its real brightness amongst a sea of about 100,000 other stars in the extended Hipparcos catalogue. We are now flying through the Digital Universe catalog from the American Museum of Natural History. Zooming further out, these stars resolve into their true 3D positions as we move further and further away from our home. Here we now see a simulation of our own galaxy, the Milky Way, with hundreds of billions of stars. In the background, we now see the about 30,000 galaxies of the Tully Galaxy Catalog. Each dot represents another galaxy. Moving even further away from Earth, we see the 3 million galaxies of the Sloan Digital Sky Survey, including the areas which we have not yet mapped. Followed by the orange dots of the locations of 750,000 quasars. The last thing to see, at about 13.8 billion light years away from Earth, is the cosmic microwave background radiation, as measured by ESA's Planck satellite, showing the time of recombination, about 300,000 years after the Big Bang. We shouldn't end at the edge of the universe, so let's open the focus panel again. Clicking on the plane icon would automatically fly us back to Earth, but we can also teleport ourselves there instantaneously by clicking the button next to it. And here we are back home. This gets us to the end of the first tutorial on how to navigate in OpenSpace. To recap, we started the program using the default profile, learned how to move the camera around using the mouse buttons and the friction modes, learned about the dashboards and the first 3 of the buttons on the toolbar to turn objects in the scene on and off, change their properties, focus on different objects, and manipulate the simulation time inside of OpenSpace. In the next tutorial, we will continue our tour through the user interface. I'll see you next time.